Everyone to another Pomodoro Joe. Today is Wednesday, January 4th, 2022, and today's LeetCode problem will be 2244, minimum rounds to complete all tasks. It's a medium level problem, and the problem statement says, you are given a zero indexed integer array tasks, where tasks at I represents the difficulty level of a task. In each round, you can complete either 2 or 3 tasks of the same difficulty level. Return the minimum rounds required to complete all the tasks, or -1 if it is not possible to complete all the tasks. And then they have a couple examples, some 2s, 3s, 2s, 4s. And then they have another example here, 2, 3, 3, and you can't complete. So this is a sort of grouping problem. The difficulty level of the task doesn't indicate how long each task will take. It just says you can group them by difficulty level, and you can perform either 2 or 3 tasks per round, but you cannot perform 1 task per round. So that's why this one results in a -1. So really all we need to do is count up or get the frequency or count of each difficulty level of tasks, and then figure out how many groups of 3 and how many groups of 2 are in that count. So for example, in this first run here, we've got 3 3s, 2 2s, and it looks like 5 4s. 1, 2, 3, 4, 5. Yeah. So with the 3 2s, we can do 1 round of 3. With the 2 3s, we can do 1 round of or 2 tasks. And then with 4s, we can break that up and do 1 group of 3 4-level tasks and 1 group of 2 4-level tasks. So the basic algorithm here will be, we'll first get the counts of each task levels. So we're going to group all our task levels by difficulty and get their counts. Then we'll go through, and for each task level, we'll figure out, can that be divided into groups of 3 and 2? And we want to divide by 3 first because we're trying to minimize the number of rounds required. So we'll try to do as many groups of 3 tasks at a time as we can, as many rounds of 3 tasks at a time as we can, before hopefully either getting to 0 or having 1 round of a 2-level task. Or not 2-level task, a round of 2 tasks. All right, so before we get started, actually, let me set the Pomodoro timer here. Set 25 minutes on the Pomodoro timer, and we'll get started. We'll start with the result, we'll set it to 0, and we will be returning our result at the end. First thing I'm gonna do is get a count of all of our tasks. So in Python, there's something called a counter. I could use a counter to get the frequency of all these tasks. I'm going to make this a little bit more straightforward, or sorry, I should say a little bit more explicit by using a dictionary to keep track of the difficulty levels to their counts. So we're going to have a task mapping. So this is going to be a dictionary where the key is the difficulty level and the value is the count of that difficulty level. So for task, in tasks, if the task is already in our task mapping, then all we need to do is increment that value. Then our task mapping at that task difficulty level plus equals 1. Otherwise, this is the first time we've seen a task of this difficulty level, so we're just going to set it equal to 1. Okay, so now that we have our counts, this tells us how many tasks of each difficulty level we need to perform. So now we could say for key, or this is task, in our task mapping, we'll get the count, and it's going to be the task mapping for that task. Now, this is where it can be a little bit tricky. I'm going to go through a little bit of math, try to do this in like the intuitive way first, and then I will, at the end, go through this a second way to see if there's an improvement we can make upon this initial solution. So in this case, we know that we have a certain count, and that count is going to be made up of a number of tasks that we do 3 at a time, so that's 3x, plus a number of tasks that we do 2 at a time, so that's 2y. And we want to maximize our x. Okay, so how do we maximize our x in this case? Well, first we'll just see how many times we can divide a count by 3. So I'll call this x equals count divided by 3. That's an integer divided by 3. Okay, so that's how many times we can do 3 tasks at a time. Now we're going to have some remainder. So that remainder is going to be count mod 3. So that's how many tasks that we couldn't complete by just doing 3 at a time. Now that remainder, if it's equal to 1, we're going to have a problem, maybe. If it's equal to 2, we'll just do a 2 level or 2 tasks at a time, and we're fine. So that if the remainder, in this case, because it's mod 3, it can only be 0, 1, or 2. If it's 0, that means we were able to do all of our tasks with just doing 3 at a time. If it's 1, it means that we did 3 at a time and we were left with 1 task left over. If it's 2, that means we did 3 at a time and we had 2 tasks left over. And that 2 can be rolled into this y, basically. So that y can be 1. So if the remainder is equal to 1, however, then we need to see if there is something. Basically, we need to not do one group of 3, so that instead of doing that one group of 3, leaving 1 left over, we'll just have a group of 4, which can be divided into 2 groups of 2. So if the remainder equals 1, well, how do we know if we can undo sort of a group of 3? Well, if x is greater than 0, that means we did some group of 3 already. We'll just unquote undo that group. So we'll subtract 1 from x. So we'll just take back that group of 3. And then our remainder, we can add 3 back to it. Okay, now if at this point our remainder is still 1 because we didn't actually have a group of 3 to do, well then we don't have a choice, we have to return -1. We didn't have any groups of 3. We haven't even gotten to our groups of 2 yet, and we only have 1 task left. We can't do this. We return -1. And now here's our y. So we've got our group of 3. And so our y will be equal to, let's see, what is our y? Our y is basically equal to our remainder divided by 2. So if we had 2 tasks remaining, we can just do 1 group of 2. If we had 4 tasks remaining, we can do 2 groups of 2. And then our result, we're going to add x plus y. So we have x rounds of 3 tasks that we can do at a time, and y rounds of 2 tasks we do at a time. And we add that to our result, and then at the very end we just return our whole result. Let's see how we do. All right. It's not reminder, it's remainder. All right, let's try that again. And that works. Let's submit this and see how well we do with all the other tests. All right, we pass. The runtime's okay. It beats 52% of other submissions. The memory is actually pretty excellent. We beat 96% of other entrants in terms of our memory usage. All right, so that's the basic algorithm. We're going to go through, get the frequency or the count of each group of tasks. Then for each group, we need to calculate how many rounds it will take, how many rounds of 3 it will take, and then how many rounds of 2 we need to add to those rounds of 3 in order to complete all of our tasks. And if it's impossible, we'll just return -1. Okay, let's go back, try a couple things. We got some time. That only took 7 minutes or so. So we have a little bit of time here. Let's see if there's anything we can do. So one thing we can do, I was going through every task in our task mapping. Well, I don't really need to go through the tasks. I really just want the counts. So instead of like grabbing the task and then using that as the key, we can go through all the values. I can get rid of this. Try that. Still works. Okay, so I'm just gonna see. I'm just curious how this will help our runtime, if it helps our runtime at all. That actually does help the runtime. So instead of using the key and having to pull that count out of the dictionary by accessing it through the key, we just accessed it directly through the values, and we improved our runtime from 52% to 77%. That's pretty good.